A quick disclaimer before we begin. The PEMF podcast does not contain any medical advice, and the content provided is for informational purposes only. If you have any health concerns, please visit a healthcare professional. Welcome back to the PEMF podcast. Today's episode is a fun one because we're talking about something you can actually see, which is PEMF's impact on the blood. From helping red blood cells unstack and move more freely, to boosting white blood cell activity, to visibly reducing signs of inflammation. This is one of the few areas where PEMF changes show up right under the microscope. We're going to break down what these visuals really mean, why they happen, and how they link into circulation, oxygenation, immune function, and things like overall well-being.
So yeah, for this episode, if you had the ability to watch, that would be advised, but we will explain everything audibly as well if you are only going to be listening. So you won't be missing out either way, but it does help a little bit if you can see the visuals. But let's go over the first section of this and the most kind of commonly seen and kind of spoken about effect that PEMF has on the blood, which is the rouleaux effect. If you're into PEMF or if you've been in the industry for a while, you might know what this is, and you've probably seen an example, as I say. Just for anyone who hasn't, what actually is this?
Yeah, so it's called the rouleaux effect, sometimes also called coin stacking. It's when the red blood cells start stacking together like little stacks of coins. A small amount of this is completely normal, but factors like long periods of sitting, being sat near Wi-Fi, stress, dehydration, chronic illness, or even just being sat indoors all day can make things like stacking more noticeable in a live blood analysis sample. When the cells are stacked like this, they don't move as freely and the blood looks denser and more sluggish under the microscope. One of the most interesting things people often see with PEMF is that these stacks break apart. We actually tested this in our office. After 8 hours of sitting at my desk, we took a blood sample of my own blood and we looked at it visually, and it was very clumped together with very few freely spaced cells. Then I sat on my PEMF mat, which was the Celerate, for 10 minutes on the evening mode that runs 8 to 10 hertz. And when we looked at it again, the difference was really, really visually clear. The cells were far apart, they're more separated, more rounded, and much more evenly spread out across the slide with a much bigger surface area. That wasn't just a one-off either. I did this test with Dr. Henning, who's been on the podcast recently. He was actually one of the reasons I got a dark field microscope myself, because at the time I used PEMF MAP for 20 minutes and the visual results were almost identical. The before slide shows a very heavy stacking, and the after slide shows the cells spaced out and moving a lot more freely in the sample.
Yeah, no, it's amazing how literally just a 10-minute session of PEMF can significantly unstack your cells and have that such night and day difference. But some people might be listening to this now and going, it sounds great, like your blood cells are now separated, but really what does that actually mean and what benefit are you getting from that?
So yeah, when your red blood cells unstack, everything in your blood just moves better. Instead of dragging along in thick clumps, the cells have more space between them, so they're able to move through the bloodstream a lot easier. That means better circulation and less resistance inside the vessels. Unstacked cells also have a much bigger surface area exposed, which naturally allows for better oxygen exchange. When the cells are clumped together, only the outer layer is doing any of the work, and the ones in the middle of the stack are just basically along for the ride. Because the blood can now flow into the smaller capillaries more freely, tissues get better delivery of whatever they need, whether that's oxygen or simply nutrients.
And yeah, exactly. So just better oxygen delivery, better circulation, better nutrients delivery, quite a few benefits just from that one little process. But we actually saw quite a few other things that are happening in the blood besides this. We got Philly from the Wellness Way podcast to do some live blood analysis on her blood after using PEMF. And she found some really interesting things that aren't actually spoken about as much in the PEMF world. I think it's because this one or these tests are slightly more challenging to run than the one that we just did. So she actually saw that inflammation dropped in her blood. Can you just explain this a little bit?
Yeah, this is a really interesting one. So just to give some credit where credit's due, this analysis was done by Shira Mastade, a live and dry blood analyst from Vitalized Nutrition. She looked at Philly's blood before and after using my PEMF mat, the Stellar 8, and the changes were really clear on the side. Before the PEMF session, her dry blood sample showed loads of these white irregular shapes that analysts often associate with inflammation. It basically indicates that the body is dealing with some kind of inflammatory load. Then after the 20-minute PEMF session on the morning mode that runs from 12 to 30 Hertz frequencies, those white areas had reduced massively. The sample looked cleaner, calmer, and much more organized.
And as we know and have covered in other episodes, PEMF has a great effect on inflammation, and we've kind of gone into how this works. But just for anyone who might have missed some of our previous episodes or might just be new to PEMF, this could be their first episode. And if it is, make sure you like, subscribe, and leave us a 5-star review on whatever platform you are. Just tell us what actually is, or how can PEMF actually reduce inflammation?
Yeah, when we talk about PEMF and inflammation, there are some specific mechanisms behind it. One lab study took human joint cells, deliberately inflamed them with IL-1 beta, one of the body's big inflammatory signals, and then added PEMF. Normally, the IL-1 beta pushes these cells into full damage mode. They pump out inflammatory chemicals and start breaking down the tissue around them. With PEMF applied, that whole response was dialed down. Inflammatory markers dropped, and the cells made more of the good structural proteins that keep the joint matrix healthy. The mechanisms behind this were the PEMF switched on a protein called STIRT1, which in turn helps shut down the NFKB, which is one of the master pathways that drives inflammation. When they blocked the STIRT1, PEMF stopped working, which is a pretty strong clue that the STIRT1 and the NFKB route is a big part of how PEMF exerts its anti-inflammatory effect.
That's one way how PEMF's effects on inflammation can be explained. There is one more pretty kind of key one and widely spoken about one. What one is that as well?
Yes, there are other ways, and the other really important piece is adenosine, which is your body's own built-in anti-inflammatory signal. Adenosine works by binding to receptors on the outside of the cells, especially the A2A and A3 receptors. What the adenosine research shows is that low-frequency, low-intensity PEMFs actually increase the number of A2A and A3 receptors on the cell surface in blood cells, joint cells, and even nervous system cells. The receptors don't change their nature, so PEMF doesn't alter how they bind it. It just puts more of them on the membrane and makes them more responsive. That means your existing adenosine suddenly has more docking stations, we call them, to work with. So its natural anti-inflammatory effect is amplified. In practical terms, that's been shown to reduce 5 pro-inflammatory cytokines while increasing IL-10, which is one of the body's calming anti-inflammatory cytokines. So if you zoom out, PEMF works on inflammation from 2 directions at once. It turns down a major pro-inflammatory pathway, the NFKB, and it turns up your own internal anti-inflammatory system via the adenosine receptors. That combination helps explain why in real-world tests like Philly's dry blood analysis, you can actually see those white inflammatory zones shrinking after a session. You're not just feeling less inflamed, the signaling environment inside the body is genuinely shifting towards repair rather than attack.
Yeah, so PEMF doesn't just have one way it positively impacts inflammation. It has multiple mechanisms that actually help it achieve that result, which is why it might actually be so effective for inflammation and a wide range of other areas, because that is actually a constant theme, kind of similar to oxygenation and to kind of oxygen levels. There are many different ways that PEMF can actually help improve these. But before we kind of get onto that, what did the live blood analysis or dry blood analysis show?
When we looked at the oxygen side of things in Philly's blood samples, the visual difference was actually really striking. In the before image, the dry blood had a noticeably pale tone. In this type of analysis, that lighter colour is usually interpreted as a sign that the red blood cells aren't carrying oxygen as effectively as they could be. After the session, the sample changed to a much deeper, richer red. That darker, fuller colour is what you'd expect when the cells are better oxygenated. So even though we're just looking at the static images, the shift in colour gives a clear visual clue that the blood was holding and delivering oxygen more effectively after the PEMF session.
Yeah, as you say, it is quite striking the difference between the two blood samples. If you're watching, you'll be able to see it is quite a pale kind of reddish color, and then it is almost quite a bright red intense color. And if you're listening, they were the major kind of two differences. But really for PEMF and oxygenation, how does it actually achieve this result?
So one of the biggest reasons PEMF helps with oxygenation is its effect on blood vessel behavior, especially the tiny microvessels that control how easily blood can flow through tissues. A key part of this is nitric oxide, specifically endothelial nitric oxide, which is produced by the cells lining your blood vessels. Nitric oxide is a natural vasodilator, meaning it tells the vessels to relax and widen. When vessels open even slightly, blood can move more freely and oxygen delivery becomes more efficient. There's an interesting animal study that demonstrates this. Researchers applied a PEMF signal directly to the cremaster muscle of rats and observed the anterioles, the very small vessels that control blood flow into tissues. What they saw was rapid and measurable vasodilation. Within just 2 minutes, the vessels widened by about 9%, and after an hour of stimulation, the dilation remained almost identical. Importantly, nothing else changed. The rat's heart rate, blood pressure, and tissue temperature stayed the same. So the vessel widening wasn't caused by heat or stress. It was a direct local effect of the PEMF signal on the microvasculature. This kind of vasodilation ties back to the nitric oxide signaling. PEMF has been shown in various studies to influence endothelial function, helping the vessel walls release more nitric oxide. When that happens, the vessels relax, circulation improves, and oxygen can move into tissues with far less resistance. So when we see blood samples shift from pale to richer red after the PEMF session, this microvascular response helps explain why it's not just the cells themselves, it's the delivery system. Wider vessels plus smoother flow means more oxygen is able to reach the tissues effectively, which lines up with what we've seen visually in that blood work.
Yeah, so we now know the PEMF can help with vasodilation, helping the blood vessels actually get wider, but can that actually help support them in any other way?
Yeah, this is a fascinating area actually. There was a study that looked at how PEMF affects angiogenesis, which is the process of forming new blood vessels, something the body relies on heavily when it's healing or repairing tissue. Researchers used human endothelial cells and exposed them to a PEMF signal at strength at around 40 Gauss and 80 Hertz frequency. They saw that the cells became much better at growing and forming new vessel structures. But the really interesting part is how it happened. PEMF actually shifted the way those cells produced energy. Normally, endothelial cells rely on a mix of mitochondrial respiration and glycolysis. But respiration can generate a lot of reactive oxygen species, basically cellular exhaust fumes that can limit healing. Under PEMF, the cells switched towards cleaner, faster glycolysis, which reduced oxidative stress and gave them more usable energy. They also noticed changes inside the mitochondria themselves. The PEMF triggered mitochondrial fission, which is a normal adjustment to the cell makes to stay energized and healthy. This shift in mitochondrial behavior helped the cells stay in optimal state of growth and repair. So overall, the study suggests that PEMF doesn't just help vessels open up, it may also help the body build new microvessels, which is a huge part of how tissues restore oxygen, nutrients, and proper circulation.
Yeah, no, that's great. And this just shows that PEMF doesn't actually just affect the blood itself, it actually affects how the blood is transported and the routes of transport almost. But we've spoken a lot in this episode about red blood cells, but there are also white blood cells. Did we have any blood analysis for this?
Yeah, absolutely. And this part was actually really interesting. When Shearer looked at the white blood cells before and after PEMF, there were only a few visible in the sample, and the ones that were there seemed almost quite static. They weren't really moving or interacting with their environment, which can be a sign that they're not particularly energized or active. After the PEMF session, the picture was completely different. There were noticeably more white blood cells visible in the sample, but the biggest change was their behaviour. They were moving with far more energy and purpose, and you could actually see them roaming across the slide, changing shape, and doing what healthy white blood cells are supposed to do. That increase in motility is often interpreted as a sign of better activity and responsiveness. So while most people talk about PEMF and red blood cells, the white blood cell side of things is just as fascinating because it gives you a glimpse into how PEMF might support general cellular activity and immune function on a micro level.
Just like with the red blood cells, it's really interesting to see how such a short session of PEMF can actually dramatically change the blood cell behavior. But now, more kind of broadly, are there any kind of research into PEMF's effects on white blood cells and anything kind of, more research based around that?
Yeah, there is actually, and it lines up really surprisingly well with what we saw in her blood sample. One of the most relevant studies looked at how PEMF affects hematology and immune cell production in mice. Instead of just looking at the blood itself, the researchers went a step deeper and examined the bone marrow, the place where the white blood cells are actually made. What they found was that when the mice exposed to PEMF, there was a clear increase in total white blood cells and lymphocytes in the bloodstream. But the interesting part is why. When they looked at the bone marrow, they saw a rise in something called CFU-GM, which are basically early stage immune cells like the starter colonies. The cell that eventually develops into granulocytes and macrophages. So PEMF wasn't just affecting the blood, it was already there. It seemed to stimulate the early production line that creates immune cells in the first place. They also measured a cytokine called GM-CSF, which is a natural growth factor that tells the body to make more white blood cells. In the mice receiving the PEMF exposure, GM-CSF levels went up, which matched the increase in immune cell production. Taken together, it matches what we saw under the microscope before PEMF. Her white blood cells were sparse and sluggish, and after PEMF, they were more numerous and actively moving. Studies like this help explain why PEMF might be supporting both the activity of the white blood cells in the moment and the production of new ones behind the scenes.
And hopefully each one of these breakdowns has helped you understand more on how PEMF actually achieves all of these effects and kind of maybe a little bit more on what's going on in the background. But some people might be thinking now, if I lay on the PEMF mat for 20 minutes, is my blood going to look like this forever? Is it just kind of a one and done? I've done my PEMF and now my blood's going to be healthy for life. Is that the fact, or do you need to do kind of continuous sessions, or as I say, is it just kind of a one and done kind of scenario?
Yeah, that's a great question because the changes we've talked about today, like unstacking the red blood cells, improving oxygenation, reducing those inflammatory markers, or just seeing the white blood cells become more active, are all things you can see very quickly and quick changes straight after PEMF. But they're not permanent. One PEMF session doesn't magically lock your blood cells into an optimized state forever. These effects tend to last up to 8 hours because, just like anything else in the body, those changes will gradually drift back towards the baseline as you go about your normal life. What PEMF research consistently shows is that these effects stacked with repeated use, almost every study follows the same pattern. A single session gives a notable shift, but it's then the repeated exposures daily or using them over a period of weeks that lead to deeper, more sustained changes. Some trials saw improvements after just a week, some after 2, and others kept improving for 4 to 6 or even 8 weeks. So the goal isn't to just do one session and expect everything is going to stay perfect for life. The goal is to create a routine. Most people start like 20, 30 minutes once a day, or longer sessions in the morning and then shorter one in the evening, for example. This keeps the blood moving well, keeps inflammation signaling calmer, and supports the nervous system consistently rather than just in isolated bursts.
So once again, like anything with PEMF, consistency is key, and the more consistently you use a system or a device, the more benefits you're going to get, and it will hopefully compound more and more over time. But I hope everyone enjoyed this episode. If you've got any questions about it or any feedback, please leave it below. While you're down there, like, subscribe, leave us a 5-star review on whatever audio platform you're listening from. It just helps us make more and more of these episodes in the future.
Thanks for listening to today's episode of PEMF Podcast.